So you can just kind of title whatever page that you're writing all this stuff on, your semester exam review. And like I said, I'm just going to kind of pick and choose a few of the questions to refer to, and then the rest of them you should be able to either look them up or you can come ask me on your own or something. So I'm going to go unit by unit. We're going to start with Unit 1. For Unit 1, the thing that I want to go over is your nuclear notation. Okay, and that is referring to question number 5 that you guys have. So you guys on your question number 5 have, I believe it's calcium. I'm going to give you guys the example with magnesium. Okay, so we have magnesium. You're going to put a little 12 down here, 25 up here. Okay, all right, so this is nuclear notation. Anybody remember what the bottom number represented? That's your atomic number. An atomic number tells you how many what? Protons. So this is number of protons. Okay? The top number. Anybody remember that? It's not atomic mass, but we call it the mass number because it's more of a counting number, right? So our mass number. We can use our mass number and subtract our atomic number to get what? Number of neutrons. Good. So for example, on this one, you guys would have had 25, subtract your 12, you would have had 13 neutrons. Okay? So if we were to then ask you, just like in that question, number of protons, number of neutrons, number of electrons, you would say there are 12 protons, 13 neutrons, and how many electrons? 12, because it's, what's the word? Electrically neutral. There you go. Okay? All right. Okay. Right underneath this, what I do want you guys to write is the same thing, but this time I want you guys to put a little +2 right here. Okay? Because this is showing you the magnesium ion. Okay? Your answer would now be 12 protons, 13 neutrons, and any idea on the electrons? 10. All right, so please remember this +2 charge means that I got rid of 2 electrons. Okay? You became more positive because I got rid of the negative stuff. Okay? So, so that's that for that. Do you guys have any questions on that?
Yeah. Wait, which ones are the ones that are the same as electrons?
Protons.
Okay, so protons.
Usually, yeah. Okay. All right, so the next question that I'm going to refer to is going to be question number 6, which has to do with your average atomic mass. All right, so your steps for finding your average atomic mass. You're usually dealing with a bunch of isotopes. Isotopes are the things that have different number of neutrons, right? Just remind yourself of that. Isotopes have to do with neutrons. Ions have to do with electrons. Okay? Just remember that. All right. So your average atomic mass has to do with your isotopes. So what you would do is you would have percentages given to you. You take that decimal in your percentage and you bump it 2 to the left. Okay? Your second step is multiply it by the mass that's given to you. And your final step is you add all those up. Okay? So I'm willing to do that example with you, number 6, and then you guys can do number 7 on your own. So what we would have here is you would have, for our percentages, 0.0742. So as you can see, I bumped that decimal 2 to the left. I'm going to multiply it by its mass, 6. And the answer you would get is 0.4452. Okay? Then I would take the next percentage, bump that decimal 2 to the left, I would multiply by its mass to get the answer 6.4806. Once you have those, notice I am not rounding or anything right now, okay? Once I have those, then I would add those guys up, and I would get the answer 6.9258, and that's when you finally can round your answer if we ask you to. So if I were to go to the second decimal place, I would end up with 6.93 AMU, and that just stands for atomic mass unit. Okay? Any questions?
So you want us to round it every time?
We'll probably indicate it, but if we don't, the second decimal place is okay. Yep. Okay, all good? Sweet. All right, so for unit 2, okay? For unit 2, do I need to review the sig fig rules one more time? Would anybody like that? Would it help anybody? I saw one nod. We'll just run through it real fast. It'll be fast. Okay. For sig figs, when you're counting your number of sig figs, it is non-zeros, sandwich zeros, trailing zero, when there's a decimal.
Wait, so say it was like a decimal and then it said 0.0007. All the zeros would count? No.
That? Is that what you're talking about? No, none of those do. Because our last rule is leading zeros never count.
So then if it was like 7, wait no, if it was decimal 7000, all of them would count?
So if we were then to put that, both of those count.
Okay.
Okay. Okay, cool. And then when you are adding and subtracting, you have to have lowest number of decimal places, meaning take a second and actually count up decimal places before you do any calculations. If you're multiplying and dividing, you count up your sig figs, so you're going to have an answer with the lowest number of sig figs. Okay? Move that up here for a second. All right, so the first one that I'm going to refer to in your review has to do with number 1. Okay? Number 1 is talking about percent error. So you will have your periodic table, and all of these formulas are in your periodic table. They're either on the inside or they're on the back cover, okay? But you have percent error is equal to your actual minus theoretical all divided by theoretical. Remember, this is where parentheses help. And they always multiply it by 100. Okay? Now, when I say those words, sometimes they just go over our heads when we start reading a problem. So, actual means from experiment. So it could be set, so we could also say you measured this much, or you measured this and calculated something. Theoretical, okay, is talking about from a book or a calculation, like a formal calculation, okay? But we're just gonna put from a book. Okay, on your number 1 in your packet, okay? So for number 2, or unit 2, number 1. If you read it, it says a student calculates the density of iron as 8.09 grams per centimeter. That doesn't mean it's not a theoretical value. He measured stuff and did it. So what I want you to do is cross out the word calculate there and replace it with the word found, or finds, sorry. So on number 1 in your review, I want you to change that to, just so you don't confuse yourself, and I'll make sure it's like this on the test, okay? A student finds okay? So change your little question to that. All right, so knowing that, now it should be a little bit easier, okay? So I'll run through it with you so you can write this on your review if you'd like, okay? The found density, the 8.09, that's going to be your actual, okay? Your 7.86 is your theoretical. Okay, because if you look at the question, he says he found that other one in a book or something. Okay, so that's where you're going to do your 8.09 minus 7.86. Lots of people like to do this in steps instead of using parentheses, and that's fine. So you would do that subtraction first. Then you would divide by the 7.86, push equals again, then multiply by the 100. And I'll let you get your own answer there. Okay. Okay. Okay, the only other thing I'm going to cover here is going to be the density. So this refers to questions 2 and 3. Please remember you have that nice little blue poster back there that has the density formula if you go blank on the test. You also have it in your periodic table, so don't guess, okay? But for your review, density is your mass over volume. And remember, your mass is usually measured in grams. Volume is usually measured in milliliters, or I think on your review it's centimeter cubed. And then density is always going to be a gram per milliliter or centimeter cubed. Okay? So if we don't explicitly say the words, you're looking for those units to kind of fill in the right numbers. Yes?
Can our percent error have like a decimal?
Mm-hmm.
So it would be 2.39.
Mm-hmm. All right, if you're going to use the triangle in order to solve for things, so if you look at the first density question, or number 2, we give you density and we're giving you volume and we're asking you to solve for mass, right? So if we're doing that, remember your algebra, okay? Multiply both sides by volume. If you're going to use the triangle thing, okay, you would write your triangle that way. You cover with your finger, you cover who are you solving for, and this will tell you that you're going to be doing density. You would do density times volume, okay? And then you're done. All right? So that's it for Unit 2. No, just kidding. One more thing for Unit 2. On question number 4, it's talking about accuracy and precision, so just a quick reminder on that. Okay? Accurate means how right are you. Precise is consistent, meaning your numbers are close together. They might not be right, but at least you're using your tool right. Maybe your tool has a problem, okay? You can see on that little data table, one of the students just needs to repeat the entire experiment because it's bad data. Okay? All right. Okay. So I'm just going to do Unit 3 on this video, and then I'm going to stop and we'll start a new one, okay? We're all good? Okay. All right, go ahead and draw a line wherever you're at. I'll let you copy it again later. So the next part that we're going to talk about is for Unit 3. I'm going to just kind of, this is the page that you guys have in your review. I'm going to scoot this down here for a minute, but I'm going to refer to one of those questions in a second. So for Unit 3, that was matter. That was talking about matter. And so the thing that we kind of started that unit with was a big flow chart, and we're just going to make a very summarized version of that. Matter can be split into 2 categories. It can either be mixture or a pure substance. Okay, you guys had a nice little pogle on that too. Okay. If it's a pure substance, that means that you're going to have to separate it by chemical means. So it means it's chemically combined. Okay? If you have a mixture, it can be separated by physical means. So that was your first lab, one of your first labs, maybe not your very first, but it was the one where we had that whole mixture of the lead and the iron and the sand and the salt, and you guys had to separate it into the 3 components. You guys remember that? Kind of-ish, a little bit? Yeah? Okay, good. All right, so that was our mixture. So we had 2 different types of mixtures in there. What are the 2 different types of mixtures? They both start with H, yes, good. So there's homogeneous or homogeneous, and there is heterogeneous. Okay? Remember, your homogeneous looks the same throughout, so we usually say the word uniform. It's a solution. If you need an example to put in your head, it's like salt water. Not salt water, Walter. I don't know what I was writing there. Salt water. Okay. Heterogeneous, you can kind of think of chunky, or you can see different pieces. Yeah, okay. It can also be dirt water, which means particles will settle. Except, who remembers which ones never settle? Start with a C. Colloids, good. Cool. So that's it for this little chart. Oh, just kidding. We forgot to finish. All right. Pure substance can be split into either a compound. Okay, and a compound is like a molecule, any kind of molecule, or elemental, meaning all your diatomics are technically elemental as well, but an atom by itself, okay? So that kind of gives you an idea. It takes a chemical reaction to make things happen, okay? And you're probably not going to split your atom ever, okay? Unless you're the sun. What?
What does compressible mean?
Compressible means it can squish all the particles together. All right, so what I'd like to do right now is focus in on question 6, okay? So on your little review, you can write it with me on here, because I want to add an extra piece to question 6, and that's just, let's label it as what type of thing it is on your little flow chart, as well as how would you separate it, okay, if it's a mixture. So looking at the dirt, what would you guys label that in your chart? It's a mixture, but what type of mixture? Heterogeneous. Can you guys, you can't see any of that. Okay. Can you see it now? Is that better? Okay, I'll write with that. Okay. All right, so it's heterogeneous. So it has to be split by physical means. What would be an idea that you guys would think of?
Oh, the filter, coffee filter.
Yeah, filter. Good, I would say that too. Filtration or filter. Okay, that usually you use for the bigger chunks, right? Okay, salt solution. Salt solution, what type of mixture is that? It's not a compound. It's a homogeneous mixture. That's the salt water that I was talking about. So this is homogeneous. Okay. So again, yep. So again, it's by physical means. Evaporation would be best. I'm totally writing off the screen. I'm sorry. You got the right idea though, okay? Remember, distillation is more when you have 2 liquids that are in a solution with each other. You'd have to evaporate the one with the lower boiling point off. All right, next one, sodium chloride. Where does that fall in our chart? That's a compound. So that's a pure substance. So we need what kind of means? Chemical means. So you can't do anything in the lab unless you're going to do a chemical reaction. Double displacement, maybe. Single replacement, whatever, you know. Okay, good, cool. Okay, water, same thing. Except that one you need electricity. But just put chemical means, it's fine. Okay, all right, so number 6 is done. You do not need to know the different chemical means, no. Just know filter and evaporation. I'm okay with that. Yep. Okay. All right, I just wanted to give you the answer to number 7, just because I don't know if I stressed it enough yet. I did say it, but the answer is C for number 7. Okay, the answer is C for number 7. Kinetic molecular theory. I'm going to talk more about that when we get to gas laws, because that's where it shows up a little bit more. But that just means that all your particles are in constant motion, even your solids. They're just vibrating there, okay? All right. Finally, I wanted to talk about question 5. So I'm back on my piece of paper again. Hold on. There you go. Just keep it organized. Okay, so number 5 is talking about intensive and extensive properties, right? So remember, you had to label things with physical properties versus chemical properties. Physical are things that you can observe, and when I say the word observe, I mean with your 5 senses. So it doesn't always necessarily mean by sight, okay? A chemical property is a part of that thing that you're talking about, but the question I told you to ask yourself is how it reacts with something. So me saying something is flammable, that's talking about chemical property, okay? If it's soluble, though, what is that?
It can dissolve.
Yeah, so is that physical or chemical?
Physical.
That one's physical. Good, all right. That's always the one that everybody misses. All right. Okay, but under physical, we also had another 2 categories, and that was just extensive and intensive, okay? So just a reminder, extensive means it depended on the amount. So for example, mass depends on the amount, volume depends on the amount, okay? Intensive, I'm just going to put does not, okay? Smiley face. Halfway through the year. All right. So that would be like density, melting point, color, thank you, boiling point, all of those, okay? And that's it for Unit 3. So I'm going to stop the video here and we'll start another one.